Good everyone. I hope you guys have an amazing day. So welcome to another episode of ANZ Salesforce podcast. So this is the first podcast for 2023. So today I have with me a very special guest, Heitor, who's a technical architect at Deloitte. So what I'll be doing, I'll be discussing with Heitor about Apex programming language. I do understand that Salesforce wants to advertise the local, right, in the form of flows or on the studio, but I still believe that Apex plays a very important role if you wanted to build a complex server-based process, or if you wanted to write a super complicated application in Salesforce. So welcome to my show, Heitor.
Hello. Thanks for inviting me, mate.
You're welcome. So, as I mentioned, right, Apex, it's been a great tool. We've been doing a lot of stuff with Apex. I do understand that there are a lot of push for the low code as well. But that being said, I have seen that, a lot of applications, especially the server-side processing, been built on Apex, which is great. Now, the biggest challenge, what I've seen, is the testing side of the Apex code, right? Because obviously, uh, Apex, or for that matter, any of the programming language, right? Unit test plays a very important role. So if I ask you one simple question, right? How do you approach testing Apex code, or what tools or strategy do you use?
Right. Uh, to be fair, that's from my point of view, that's a very interesting and important question. And I don't always see projects giving good relevance to mainly unit tests and automated tests as well.
Yeah,
My point of view is that unit tests, they need to, well, as the name says, they need to test units, right? So
yeah,
unit tests needs to be able to test small parts of your application. Uh,
right,
Other programming languages, as well as Apex, they give you, well, I'm focusing more about Apex here. Apex gives you what they call the stub API.
right,
It's a very simple but powerful API for testing. Uh,
right,
I normally in my projects I use the fflib Apex mocks framework, which is entirely based on the stub API, and it's a sort of for the sake of a better word, it's a sort of a replica uh, uh, of a Java framework.
right,
So I use that so my main idea for that is to use a stub API and obviously a fflib framework for that, to isolate units in the code. So a simple example, I don't know, you have a REST controller, and that controller invokes I don't know, a service class, and the service class invokes a selector class, right?
right,
If you use the sub API and fflib or whatever, you can isolate the I guess downstream calls of your Apex code. So if you
mhm,
are testing your controller class, you can mock the service class and then tell the controller on the context of a test, tell the controller what behavior the service class should be doing. Uh,
right,
and that way, you don't care about what actually the service class is doing. That's a problem for another test, for another unit test.
right,
You just mock behaviors for your controller and say, right, for this call, the service class should be returning you, I don't know, some value, and doesn't really matter what the service class does. The controller needs to be able to know what the result of the service class is. That's the only thing, right? You need to
right,
be able to send the parameters and understand the result. You don't need to know what they're doing uh, in the back scenes, right? And using sub API and primarily with fflib Apex mocks or I don't know, there might be other frameworks out there I just have never used. But using a proper framework, you can isolate the layers of your application and making your test to test only that unit. So for example, the controller test will only test the controller. You don't have to set data. You don't have to do any setup apart from the setup specifically for your controller. And the same concept applies for when you're testing your service layer, where you mock, let's say, the selector. So you don't have to do DMLs on every single test class, right?
Right.
So you're just testing a logic that is happening in the class. If that class doesn't have a SQL query or anything, which we'll normally leave for the selector class anyway, or selector layer,
Right.
you can perform unit tests, properly saying, which then results in, from my point of view, more assertive tests and a lot quicker as well. The test execution time is a lot lower because you avoid DMLs and any other userless execution for your test context. But it does result in you having to have more tests, I would say, or more unit tests, which from my point of view is by far not a bad thing to have.
Yeah, that's right. I totally agree with you on that. I mean, and FFlib, I do use FFlib a lot. I mean, we use FFlib anyways, right? But the only thing, though, I would like to mention that someone who never used FFlib might be a little bit of a learning curve. I mean, maybe just to get used to it, the how to do certain things. But apart from that, I believe, I personally believe, especially on the Salesforce side, Apex, if you wanted to do a better unit test, FFlib will give you that flexibility. So now coming to, based on that unit test, right? Obviously, I believe you can do a lot of tests using, external libraries or Stub API. And now, what about the performance issues that comes from an Apex code? Can we do such sort of testing using Apex test, or let's say, what are the common performance issues that can arise from an Apex code?
Right. Yeah. Well, I think performance issues is probably a broad statement, but I'll try and keep my answer short. So again, if we take test as an example, obviously unit tests will give you a good, I would say, a good overview, or of tests or of executions in your code, of pieces in your code that might not be very performant. But honestly, it's very hard, mainly in Salesforce, to find or to test performance using unit tests. To be fair, I don't think this should be the approach in a way. There are other types of tests that we can use to cover performance. Normally, unit test, the developers, they set the data only for the scenario that you're actually testing your unit or your code. But in real scenarios, you have some production orgs will have millions of records, and that's where the performance could at least from the cases or from the orgs that I've worked on, most of the performance issues were mostly because of volume of data, and unit tests won't give you a good response for in terms of volume of data. So if your code is not performant due to the volume of data in your org, the unit test won't give you any of that. But in general, and I just forgot your question. What was that again?
Yeah, it's about the common performance issue that can arise in the
Oh yeah.
Apex code. Yeah.
Yeah, well, yeah, which not necessarily, well, Apex code, but I think the most common that I've seen out there, which is probably I guess, rule number one of Salesforce, or at least top 10 rules of uh, uh, developing in Salesforce is the lack of bulkification, right? Uh, Mainly in triggers and if, it's we're talking about Apex here, but it's also very common to not bulkify flows and previously when, well, process builder is still a thing, it'll hopefully get deprecated very soon, but
Yeah.
process builders, they're not bulkified. So any uh, automation that you end up writing in your org that uses process builder as well is not performant. Uh, yeah, since the first deployment, right? It's not
Yeah.
going to be performant. If you have a large volume of data, that's going to be very bad.
Yeah. That's
So yeah,
right. Yeah. Yeah. Go ahead, please.
no, yeah. So yeah, just going back, I guess bulkification is one of them, or probably the most. Yeah, I guess the most important one.
Yeah, I totally agree with that, the bulkification. And since you touched on the flow side, right? I mean, I have an experience on one of the project, maybe if you remember one of the projects I worked on where we were struggling to get the flow working because of the bulkification. So I have to redo most of the stuff in the Apex to boost the performance. So yeah, that's one of the challenges, right? I mean, when a developer writes a code or a flow, if they don't keep the bulkification into consideration, it can cause a lot of issues when the code or flow have to handle large data volumes.
Yeah,
So
yeah,
yes, yeah,
yeah. Yeah, and I think from the other side, it's uh it's also uh important. Like for example, uh when we use reflection in Salesforce, for those who don't know
mm,
what reflection is, the type dot for name thing. Well, a
yeah,
lot of
yeah,
people have used that before. That is that will normally make your code more elegant, I would say,
right,
more
yeah,
readable, more easier to maintain. But on the flip side of that, you do lose some performance. I think around CPU time. Uh,
yeah,
so you know, sometimes, and to be fair, I normally uh go for or choose for my code to be elegant anyway.
yeah,
But sometimes you have to make a decision and let's say not use reflection in your code if you're having some really heavy processing in Apex. Uh,
yeah,
then using reflection might not be a good idea. So there are I've seen different performance issues out there, and to be fair, it's a case by case to kind of understand what to do to kind of solve that.
yeah. That's right. Reflection is an interesting topic, though. I've used a lot of reflection in C sharp, but in the .NET framework, they kind of created that to keep the performance into consideration as well. So, but yeah, I agree with you what you said on that. Now, you briefly touched on triggers when we were talking about the performance, right? So, can you tell me some of the best practices for designing and working with triggers in Apex?
Oh yeah, right. Yeah. So again, as I said, it's probably like on the top 10 of best practices in Salesforce for development is you know, uh, bulkification of triggers, right? No matter
Yeah,
no matter if you're using a framework, no matter if you're putting some logic inside a trigger, which again, it's not something I would recommend or you do, but as long as your logic is bulkified, then your code is not as bad. Obviously, then after, so bulkification number one, and then after that, I again do not suggest, and we shouldn't have in a way multiple triggers for a single object. I think I'm going to just say some things that should be straightforward, or should be things that everyone know when they start working with Salesforce. But yeah, some people might not have that knowledge. So buckification, single trigger per object. And for those who don't know, having a single trigger per object guarantee that you know the order of execution in your code. And ultimately having a trigger framework. There are quite a few out there, but even the most simple ones, they do a good job. And then it kind of enforces you to move your logic into a proper Apex class, and then use other downstream classes or layers that you want to use. So yeah, I think these are the main ones. Buckification, single object or single trigger per object, and make use of a framework. And
like you said, as you said, right? I mean, it's always a good practice not to write the business logic inside the trigger, because the code can get bigger, right? And then it's gonna get messy. That it's good to have a framework, right, where you extract the logic to maybe a separate class, or just to simplify things.
Yeah, and normally, those triggers normally triggers you're gonna build a logic that you might want to reuse at some another point in your application, right? And you just reference a code inside your trigger to like avoid duplication of code or things like that. So if you build a logic in a common kind of area or common class in your code, then you can reference that class from your trigger and also from wherever else that you need to invoke it from.
Yeah, that's right. That's cool. So obviously, when we do Apex, right, there will be a possibility where you might encounter errors or exception. So how do you handle errors and exceptions in Apex code?
Right. I guess the most simplistic way is having try catches where we should have them. Try catch is not an option for your code to be or to not have any errors or exceptions. So make use of try catches, but making sure that you know the exceptions that you're catching. And obviously, again, it's very common to use some sort of logging framework, or people could just use standard a custom object, and just put some stack traces in there and log errors in there. But having track or traceability of errors that or exceptions that are thrown in your org is very important. So if you're using one by yourself, like if you're creating error log custom object, or if you're using something more more elegant like Nebula Logger or other frameworks that have up there as well, and they're all open source ones. It's I guess it's crucial to have a error logging error logging framework, or something to capture errors that are thrown in your and I guess the most important or I guess more important than that is having a process or something to go through the errors that are happening in your org, right?
Right.
Catching exceptions and putting in a record and forgetting about it is it's not the best approach, and we've seen that quite a lot.
Yeah, that's right. Then it's just gonna add to the data storage if you're not gonna pay attention to it. Yeah, that's right. Yeah. So now another important question I would like to ask, right? Obviously, when you're building stuff using Apex code, security plays an important role, right? Who sees what, the data. So how do you ensure that Apex code is secure and it complies with Salesforce security standards?
Yeah, right. Uh, I think so my point of view is most of the times, or well, I don't know, most of the times, but probably, we want to show only what the user has access to, right? So translating to Salesforce terms, only records that are shared with the
Yeah.
user running that or executing or viewing a page or whatever. But sometimes, mainly for backend processing, you cannot want the user to see well, everything really, or the user that is running that backend execution. You kind of want them to see everything. So, again, talking about layers of your code,
Yeah.
I normally put all of the SQL queries running on one layer of my code, which I normally call selector. So I have selector classes, a selector class per object type. So I have an account selector, context selector, or whatever custom object selector. And I normally give inherited sharing to that class. So that means that the selector class itself doesn't care, or it's not the selector class who is dictating what sharing it should be using to retrieve those records. And the reason for that is that normally, upstream classes like controller or or REST resource classes, they are the ones who should know whether the user should have access to all the data and the database, or just to the subset that they actually or that is shared with them. So if you use inherited sharing in the selector class, that sort of gives you that flexibility. So so it inherits sharing from the class that is actually calling it.
Right. That makes sense. Yeah, that's right. I mean, it's normally controlled by the class which is calling it. Yeah,
Yeah.
that's
And that's from a sharing point of view, right? But if we want to
yeah,
look from a field level security point of view, then Salesforce gives other keywords for SOCO, so we can strip out these the custom fields or fields that the user don't have access either from the profile or permission set or whatever. So if the user cannot see that field, so they shouldn't be able to query for that field.
yeah. It's like if it's security enabled, right? That's in the local query
Yes.
English, right? Yeah, and I think that I remember that in LWC, right? When you are using wired decorator, it automatically takes care of FL, the field level security and other stuff. So yeah, that's a different topic. Okay, that's cool. That's appreciate it. Thank you very much for that. Now let me talk briefly about deployment and packaging, right? So do you have any consideration? Well, what are some consideration for optimizing Apex code for deployment and packaging?
I think, and that goes back like to design patterns and stuff, right?
Right.
I think your code should primarily uh, well, I don't want to sound cliche, but like the solid principles, they sort of go back to your code, and I guess mainly the single responsibility one, where you have small bits in your code that will do small pieces for your business logic, and yeah, I guess avoiding interdependency between your code. So one class that calls a subclass, and then that subclass calling the parent class again. That sort of cycle in your code, we should avoid doing that. And thinking of deployments and Packaging, obviously, we cannot forget again about unit tests. Coverage, as everyone probably knows by now, coverage should be above 75%. Doesn't mean that 75% is a cap. We should aim for 100%. I know it's hard sometimes to get 100% of code coverage in Salesforce, given that some stuff in Salesforce you just cannot mock or set up data or stuff like that. So yeah, making your code small and tidy, I would say, and cater for unit tests, and always aim for 100. If you're aiming for 75%, it means that you don't really know what your code is doing, or your code is too complicated for unit tests. Then it should be refactored anyway.
Yeah, that's right. I've seen some of the code which I call spaghetti code, code smell. So coming back to that same question about optimizing. So that leads to my final question. That is, do you believe that design patterns are important when you implement stuff in Apex? Like you mentioned, a solid principle, right? Solid principle have like single responsibility principle, open close, and there's the Lix I can't pronounce the name. The Lix I always get it wrong. Yeah, but I know what that means. So do you believe that, or for that matter, any design pattern is a good point to start with when you're building Apex code?
Yeah, exactly. To be fair, people don't need to know what all the design patterns are and what all of them do and what problem they solve or anything like that. But I think developers, they should know what a design pattern is and why design patterns exist, right? Because the main idea behind that is that, again, to make your code follow some principles, right? You don't want to duplicate code in your code base, right? It makes your code very hard to maintain. If you have duplicate code and you need to change some business logic within it, you have to remember to change that in 2 different places, sometimes 3, 4, whatever. So design patterns will kind of guide you or guide your code to not have duplications or to be more readable. Because again, when you're writing a code, obviously who's going to read that code is the compiler. But the code has English words in it. The compiler doesn't know about the English words in it. But your code has English words in it so that other developers can come and read, right? So more simple you make your code to be read by someone, the better it is for maintainability, right? Sometimes I am the person doing the project, but I might not necessarily be the person doing the support of that project, right? So I'm gonna deliver, or I'm gonna hand over my code to someone with not the same context as I had at the time I was developing the project. And when they take that to provide support, if they cannot read what is in there, as you just said, if my code is spaghetti, lots of ifs, lots of else's, they don't really know what's going on there. You make the other person's life very, very hard. And obviously we want to avoid that because it could be, us doing the support, as it's, at least from my point of view, I've been on that side of the project, being support after go live and having to deal with some very weird code.
Yeah, I can relate to that. So the only thing I often tell, right, someone who wants to work with Apex, please don't write Apex as a procedural, like as if you're coding in a procedural language. It's an object-oriented language for a reason, right? So where we have a concept of inheritance, interfaces, abstract classes, these things are there for a reason, so that, you can write a better, good quality code, easy to maintain and scalable at the same time, right? In the future, for any future enhancements.
Yeah, exactly. Scalability is the thing, right? It's not, sometimes you want to make your code easy, or easy enough to be able to add new features. And, by adding a new feature, you shouldn't be breaking things. But if your code is a mess and it's spaghetti, you have a high chance of breaking something that has nothing to do with the feature that you're adding. So having your code, I guess, modular in a way will, following OOP principles. That's
and people should not be thinking too much about eating Italian food, right? When they write code, otherwise end up making pasta out of it, which is not really great. So that's all I wanted to ask. It's been really great to have you, right? So thank you so much. We covered a lot of things. I hope who are listening to us today will find some value, and hope that they will start writing better code if they were not using any patterns or Logger framework. So I hope this will help who wanted to get into Apex, I presume, and to not only to get into Apex, but to write Apex code in a good way or in a better way. So thank you so much for your time, mate. Appreciate it.
Thank you. Yeah, thanks for the invite again. Yeah, it was a pleasure.
Thank you.